This is your notes for the polygon interior angles theorem. In the previous video, you went ahead and you hopefully understood the proof for why the sum of the interior angles for a triangle is equal to 180 degrees. We're going to go ahead and do an activity where you are going to try to figure out the sum of the interior angles for a random polygon. It's not a triangle anymore. The more sides it has, for instance, quadrilateral, pentagon, octagon, heptagon, the different the answer will become. So that's what we're going to do today. Just a quick reminder of the names that I'm going to maybe be using, maybe not, and how many sides it is. Just recall, for instance, if it has like 20 sides, yeah, I'm not going to look up what is the name of a 20-sided polygon. I'm just going to call it a 20gon. So this is the really big question that we're asking ourselves. We already know the triangle is equal to 180, but now what about a quadrilateral? I want you to notice this shape right here. By definition, this is a quadrilateral. Most of you will probably think of the two really basic ones, a rectangle and a square. Those are also considered quadrilaterals. Most of you can also figure out what these angles are right here on the inside, and you can go ahead and tell me what you think the sum of the interior angles are. And you'll probably be right if you remember the definitions of a square and a rectangle. But now my question to you is it the same answer for this weird looking shape? And then let's just keep going, right? This is 3 sides, this is 4 sides. What about 5 sides, i.e. a pentagon? If I were to add up all the angles right here on the inside, what's the number going to be, right? Especially if you don't have a protractor or things like that. So here goes where the activity starts. On your paper, you're going to go ahead and I'll give you the option. Draw any quadrilateral you want. Just remember it has to follow the polygon definition where it's a closed shape. One side will only touch 2 other sides at its endpoint. It can't be on the same line, right? You need to have like a little, think of it like it needs to change direction, okay? And now my question to you is this part right here. How can we break up that shape into something you already know, something that you don't have to assume anymore? And a really big hint should be, we've already shown what the triangle is. A triangle is 180 degrees. So go ahead on your paper, just sketch out a quadrilateral, try to break it up into triangles, right? Either with an S or no S, triangles. And then see, can you figure out, based off of what you did, what is the sum of interiors for a quadrilateral? The quadrilateral that I decided to draw was this one right here in front. And now in order for me to create triangles, 3 sides, all sides are straight, right? Because it's a polygon. The only line I can draw is basically from here to here. So I form 2 triangles. I cannot draw another line because if I were to draw it from this one all the way to this one, I don't have triangles there. This here is not considered to be a triangle. It's actually something else which I can't remember right now, but there you go. Okay, so that's the only line I can draw. Let's say, for instance, you decided to go with the more basic shapes. You're going to get the exact same answer. You can only draw one line that'll create 2 triangles. One extremely important thing, and this is for my people that are just a little bit more creative. Why does this not work? Why can't you create 4 triangles here? So if you really think about what the question is asking, you only care about the angles here in the interior. If you notice, all of these 4 triangles are including the angles around there. The yellow angles there have nothing to do with the actual answer that we care about. That is exactly why you cannot draw that extra line to create more triangles. You can I mean, you can technically also just draw it the other way, but you're still only going to get max. So that's the really important part. You're only going to get max 2 triangles. And so then let's really think about the question, right? If I form 2 triangles and each one is 180 degrees, then together that just means for any quadrilateral, it'll be 360 degrees. Now, if we go ahead and we look at the angles, it makes sense. So the first triangle, it has this angle, that one right there, and then that one right there. Once again, different colors, different numbers of lines just to indicate that they're different. So we have this angle, we have that one, and then we have that angle on top. Now, if you really notice, if I were to add those 2 angles, it creates the long one on the top. If I were to add these 2 angles, it would go ahead and create this here. So it covers every single interior angle inside that one. And that's why it's 360 for a quadrilateral. So let's officially move on to the actual activity that you're going to do today to figure out the answers for any polygon now. Okay, so go ahead and copy down this table, and we already actually have some information that we can fill in. So let me zoom in for you. A triangle has 3 sides. Of course, it's one triangle that you can form, so you have 180 degrees. A quadrilateral has 4 sides, which we saw that we can form 2 triangles, and so then it'll have a total of 360 degrees. Now, if we just continue this pattern, we're going to go ahead and go with pentagon, then hexagon, heptagon, octagon, and then an n-gon. This is the goal at the end. Trying to figure out if, let's say, I don't tell you how many sides, I just tell you n-gon, can you tell me what the sum of interior angle is? So that right there, this is the end goal. The rest of the work is here to help you, to guide you. So actually try it out. So right now, let's start with pentagon. Draw a pentagon on your paper and try to break it up. If you need it, let's do a reminder. Pentagon has 5 sides. Hexagon 6, heptagon 7, octagon 8. Your pictures don't have to be perfect. Go ahead and just Google one and then copy it, from your screen. Careful, don't scratch your screen. If you are super confused, let's do pentagon together. If not, pause the video, see if you can figure it out by yourself. If you really need me to do it, I'm going to go ahead and draw a pentagon, which is 5 sides. So we have 1, 2, 3, 4, 5. All right, notice how it's not pretty, but whatever, it has 5 sides. That's what we need. So if I'm going to go ahead and create triangles, I can go ahead and draw a dot there. That does not work because that's not a triangle. Same exact reason for that one. So I go ahead and I can draw it there. That'll create my first triangle. Continuing with this pattern, I can go ahead and I can draw other triangles. I choose that one just because I want to. Cannot draw that one because it's not a triangle. Cannot draw that one. Again, not a triangle. So I only have this option, right, to go to this corner. So then I have my second triangle and my third triangle. So what this means is I went ahead and a pentagon, which has 5 sides, I can break it up into 3 triangles. So go to your table and let's go ahead and let's fill that out. So a pentagon has 5 sides, 3 triangles, and so we can go ahead and do the math. And that'll give us 540. Pause the video, continue to do the work, and see what you get when you come back. Okay, so I hope that you went ahead and you filled out the rest of the table. For those of you guys that didn't, right, let's go ahead, or if you want to check your table, here goes the finished version of the table. Okay, it has all the information there, so go ahead, check your work, see if you got it right. I want you guys to notice one quick thing, right? This here is how I decided to break up the triangles for an octagon. You don't have to follow the exact same way. In fact, maybe you have different triangles in yours. It doesn't matter. What will matter, though, is the same amount of triangles. I was able to get 6 triangles. you should also get 6 triangles. And now for the most important part. What happens when you're talking about an n-gon? So if you really think about it, by definition, an n-gon will have n amount of sides. For instance, if you say 5, like a 5-gon, I mean, it's the same thing as a pentagon, but it has 5 sides. Now, notice the pattern, okay? There's always a pattern in everything. So if you have n sides, you're going to have 2 less than that. So we can go ahead and do n minus 2. And then if we have, so that right here, this is a number. We can figure out, right? If I tell you n is equal to 25, so for instance, a polygon that has 25 sides, you know you're going to be able to form 23 triangles based off of the pattern. And so what that means is to figure out the sum of interior angles, we would go ahead and do 23 times 180 degrees, because that's what you're doing. You're adding 180 23 times. And so then our equation becomes n minus 2 times 180 degrees. I'm going to go ahead and put parentheses around that just so you can see it. So really think about what this right here equation is saying, because that's the most important equation for this lesson. So it has 2 parts to it, okay? The first part, n minus 2. That is going to tell you how many triangles we can form, right? How many triangles you can form in the shape. And then the 180 degrees part, the times it, is basically you just keep adding 180 degrees every single time. And so this right here is the equation that you need to know. So let's go ahead and let's think about how to apply this equation right here, okay? So you have to understand, this is going to tell us the sum of all the interior angles of any polygon, which is really, really nice. We can check it with a really easy example, right? Let's think about, of course, a triangle. So for a triangle, n is equal to 3 because it has 3 sides. So to use the equation, I would go ahead and I'd plug that in. 3 minus 2 times 180. So 3 minus 2 obviously is 1 times 180. And boom, that's 180 degrees. So it checks out for triangle. If we go ahead and try to do it for a different shape, let's say a quadrilateral, then n would equal to 4. So we would go ahead and plug it into the equation. 4 minus 2 times 180 degrees, which we can go ahead and do that. And this is exactly what we keep getting over and over in our table, and if you did it by hand. But now it's really nice because you can go ahead and use this equation right there. So let's go to the first example and see how can you actually use it. So the problem is asking you, find the sum of the measures of the interior angles. So that right there is sort of your telltale sign to use the equation of a 16-gon. Notice how I'm actually giving you n equals 16 here by just calling it a 16-gon. I am not going to go ahead and tell you every single time in the problem what is n equal to. You need to be able to read the problem and see which one it is. So if we recall, our equation is n minus 2 times 180 degrees. And that is equal to the sum. Okay, sum of interior angles. So all I have to do is basically just plug that in. 16 minus 2 times 180 degrees. So that is 14 times 180 degrees. This means there are 14 triangles that can be formed in a 16-gon. That's what it means. And then we just go ahead and multiply that, and 2,520 degrees. And I definitely needed my calculator for that. I'm not gonna just like let you guys think that I knew this by heart or something. So there you go. This would be our answer for this question. The sum of the measures of an interior angle for a 16-gon is 2,520 degrees. Let's go ahead to the next one. Just reading the question, you have to understand what you're looking for. So that part right there tells us what we're looking for. How many sides does the polygon have? So based off of this equation, we actually don't know what n is equal to. So that's what we need to figure out. So we're kind of working a little bit backwards. So let's go ahead and let's plug in what we actually do have, or let's just pay attention to what we do have. So I have this number here, 3,600 degrees. And if you read the problem, it's basically, that's what the interior angle is, the sum of it. So it kind of gave us the answer to start with. So it gave us the answer. And now this is what we need to figure out. Right? What n value works where the answer is going to go ahead and give me 3,600. There's a couple of ways of doing this. It is 100% up to you. I will go ahead and show you what I think is the easiest, and then I'll also show you the longer version. For me, the shortcut version is you really just need to understand this right here. Right? You're multiplying. You're multiplying 180 with this number here. So what you can just do if you're trying to isolate the variable, we're going to go ahead and divide by 180 degrees. And I know for some of us, we're already thinking like, okay, this is super procedural, but you really have to think about what this right-hand side even means, okay? So this cancels out because both of them equal to 1, and then we bring down n minus 2, and then what do we get there, okay? This is what you really need to understand what's going on. So what you're doing there is you're basically just determining how many triangles are formed in 3,600 because you're dividing by 180. And so after, plugging into the calculator, we get 20. So what this means is there are 20 triangles. Now, some of you might stop here and think that's the answer, but it's actually not for two reasons. 20 represents how many triangles there are, but that doesn't represent how many sides it has. If you recall, there's a pattern. It's either 2 less or 2 more, depending on what direction you're going. Since if you look at this equation, we're going ahead and we have the equation n minus 2 equals 20, I can really just go, plus 2, our super procedural way, and we get 22. So that is the answer. 22 sides. Now, if you recall the table was always 2 less. So if I gave you like a quadrilateral, which has 4 sides, it has 2 triangles. So it's always 2 less. So that's where the 20 comes from. So this is one way of solving it. I can go ahead and I'm going to show you a different way of solving it, which maybe some of you are going to be a little bit more comfortable with this way, but it really just depends on you. So the other way of solving it is using the same equation, right? That's not going to change. You still have to use that equation. But let me go ahead and let me do it on the side. So we still have n minus 2 times 180 equals, 3,600 degrees. Now, I forgot the little dot there. So what you can do is you can distribute that 180, right? Because it's being multiplied, so you're distributing anyways, and that's why I wrote the parentheses. So we would get 180n minus 360 equals 3,600. The 360 comes from multiplying 180 and negative 2. Okay, so now let's go ahead and let's solve this equation. Now this is where it becomes super procedural. Okay, so plus 360 on both sides because we're trying to isolate the variable now. That equals 0. So then we get 180n is equal to, what is that? That is 3,960. So 3,960. You see, here is where it kind of bugs me, right? Because there's no context here whatsoever. Like, what does this number represent really when we're talking about forming triangles, breaking up the polygon? It really doesn't tell me anything. As opposed to over here, this work, it makes sense to me. 20 represents the amount of triangles. Adding the 2 because that's the pattern. So the answer is 22. The second way of solving it, right here, this one, it's super just procedural. You're stripping away a lot of the context and you're just kind of just doing math. I mean, I'm pretty sure there's a way or there's a reason for some of these steps and like you can go back to triangles, but it's not really intuitive, which is one of the reasons why I kind of don't like it. So then we would go ahead and we divide 180 on both sides because, that's what you're supposed to do in solving for a variable. And so then we would go ahead and we would get 22. Let's do a couple more examples and see if you guys get the hang of it. But we really already covered most of what you guys need to know. So we go over here to this one. Let me zoom in so you could avoid the work. Notice how the directions just say solve for x. So you need to form an equation. But now the whole point is, well, what's the equation? What can we do? This is a quadrilateral because it has 4 sides. And so then using the equation, or just remembering it, because some of these are going to be shapes that you already know, we have 4 minus 2 times 180, which is going to equal 2 times 180, so it's 360 degrees. So since it's a quadrilateral, all the angles, all the interior angles, have to add up to 360. So what we can just do is go ahead and do that. 4x minus 2 plus 108 plus 2x plus 10 plus 82 is equal to, and now this is where this work comes in handy, because now you can say it's equal to 360 degrees. You can go ahead now and solve it and see what you get. I will do the work really quickly here. To solve this equation, you can do it several different ways. It is up to you 100%. I'm going to go ahead and I'm going to combine like terms on one side and then just start doing it. So you can either skip ahead, go to the next example if you don't really need this. If you do, then go ahead and watch it. So 4x is like terms to 2x because they both have a variable, and then negative 2 is considered to be a constant because it doesn't have a variable there. So I'm going to go ahead and I'm going to underline all the constants. Notice how I'm only focusing on one side, because I can't go ahead and combine like terms across the equal sign. That's why I drew the line there. And so after that, we can go ahead and do 4x plus 2x, which is 6x, and then I can do negative 2 plus 108 plus 10 plus 82. Use a calculator. Stop trying to do this in your head. Okay, so the answer ends up being 198. So plus 198 is equal to 360, and then we could go ahead and isolate the variable by subtracting 198 on both sides, and so we get 6x is equal to 162. Sorry, that looks really, let's just zoom out so you guys can see that, is equal to 162, and then we will go ahead and divide by 6 on both sides. And so x is equal to 27. Understand that the only way this was possible was because you knew it was equal to 360 by doing this work first. Okay, so reading the directions, right, solve for x, you have to slow it down. You have to think about, how can we do this? How can I go ahead and figure out numbers and stuff? And for those of you guys that maybe you know already about trapezoids and how paralines work and stuff like that, you could also figure this out a different way. But for right now, this is how you would figure out in this section. Let's go ahead and move on to the next example. Pause the video. At this point, you should most likely be getting to the point where you're able to do them by yourself. Read the directions and see what you can do. So we need to figure out the unknown angles, which, if you notice, there goes our 2 variables. So we're pretty much going to do the same thing we did in the previous example, except now this is a different shape. So you count how many sides there are, right? It even tells you there it's a pentagon, but just to be sure, there you go. 1, 2, 3, 4, 5 sides. Okay, so 5 sides. So if you go to the table that you guys already filled in, or you just very quickly do the math, we can go ahead and do 5 minus 2 times 180. And this is very important in you not having to memorize this. You wouldn't have to memorize this equation, right? You can just go ahead and use it whenever it's needed, as opposed to trying to force yourself to memorize it, which is pretty actually kind of hard. So anyways, right, it's 540 degrees after you do that math. It'll be 3 times 180. And so what you can go ahead and do is, once again, set up your equation. So I'll start with this angle, just because it has a number there as a variable. So it's going to be x plus, you could go whichever direction you want. You just have to include all of the 5 angles. So I'm going to go ahead up to this one. If you notice, it's a little box, so that means it's 90 degrees plus, I'm just going to keep going in the same direction, x plus 90 plus 90. Just make sure you wrote 5 things. 1, 2, 3, there you go. And then we know that's equal to 540 degrees. What you can do now is same thing as before, isolate your variable, solve. Notice how I always underline with the same number of lines depending on if they are like terms or not. So x and x gives me 2x, 3 90s together give me 270, and that is equal to 540. You would go ahead and solve by subtracting 270 on both sides. 2x is equal to, yeah, I don't know what that is, so minus 270. Nice, it's 270, wow. And so that divide that by 2, because that's the next step. So x is equal to 135. And so there you go, right? We can easily check our work and see if it makes sense. We can go ahead and do 135, add that twice, because there's 2 x's there, and then go ahead and add 90 3 times, because there's 3 90-degree angles, and if that adds up to 540, then we know we are right. So 90 3 times gives us 270, and then adding 135 twice, which would give us, again, 270, and so then there you go. 540, which checks out, so my final answer is x equals 135 degrees. Let's go ahead to the next example. A little bit different, so read it, pause the video, and try to figure it out. Since it's a 14gon, we can go ahead and we can think about what all the angles should add up to. I know some of you might look at this right here and say, well, doesn't it mean it's going to add up to 2014? No, read the sentence. You have to be very careful. The measure of 13 angles of a 14gon add up to 2014. So they're basically giving you already 13 angles. You have to get the last one. So let's go ahead and let's figure out, first of all, if it's a 14gon, what is the sum of the interior angles? So we could go ahead and do our equation. 14 minus 2 times 180 degrees, which is equal to 2,160 degrees. Now, let's just think about that number. Does it make sense? If they tell you that 13 angles add up to 2014, then obviously this number had to be bigger because you're still missing 1 angle. And so let's go ahead and let's think about, well, how can we figure out the final answer? So 2,116, this is all 14 angles. And 2014 is 13 of the 14 angles. And so you really can just do this by, either subtracting. You could even make up your own equation if you want to, but that's sort of overkill. But I will say some students, you really need to do that because it'll help you. So for instance, the really lazy way would be, well, I'm just going to go ahead and do that right there. And I say lazy, but I should probably say, lazy, but you're still doing your work way. Okay, so 2,116 minus 2014, which is equal to 146 degrees. And so we know that the 14th angle is equal to 146 degrees. That'll be our final answer. Now, for instance, let's say you're just the type that you need the angle, an equation, you can go ahead and set it up. So we know that 13 angles equal to 2014. We're missing 1 angle, and we know that it has to add up to that right there. It's just a very nice way. For some of us, we really need to see the equation, like why it works. So doing it here like this, we can go ahead and just subtract 2014 on both sides, and that's how we would get the exact same answer. Okay? And so that there And so that there is two different ways of solving this. I mean, you don't have to do the equation, but some of us will probably need it just to be 100% sure. And this is going to be the last example. I hope that this was helpful for you. Let's go ahead and let's just recap one last time the super important equation that we figured out. So let's do a recap. What you did was you got polygons and you broke them up, right? You broke them up into something that we know, triangles, because in one of the other videos, you were able to prove that the sum of interior angles of a triangle is 180 degrees. So after wow, I did not notice, I totally misspelled that. Polygons. Oh, polygons. There you go. All right, so after we went ahead and we did that, we came up with something that is super important. That's basically the basis of this lesson. This equation right here. Okay? And it's going to be really important. I haven't been writing it, but it's in the video. It's in the name of the video. Sum of interior angles. Okay? This is the equation for it. Now, I want you to notice how not once in the examples did I ever say, if n is equal to this, then figure out the sum of interior angles. You have to read the problems. You have to be a little bit creative. And most importantly, you have to be patient with yourself. Some of these problems, they're not going to seem that straightforward, but the math that you're going to have to do is not really high level math. Notice how all we did was really just, you need to know how to solve equations, basically, and just you need to know how to isolate the variable. Okay, so that is the end of this video.